It's the best time of the week.
I love this.
Yes.
Yeah.
One day early, too.
I know, what a treat. We don't want to talk about you actually taking a day off. We'll talk
Or going
about that.
skiing or
Yeah,
something.
whatever.
So, yeah.
Anyway, we are glad that Jacob Morse is here today for another Morse Code of Weather. Today we're learning about weather satellites.
It's a timely Morse code of weather, too, because this just happened
So
about
great.
a half hour ago.
It sure did, yeah.
A new weather satellite was launched into space, and we'll be talking about that and the history of weather satellites, because they're a really important part of how we observe the atmosphere as well as the Earth as a whole. So this new satellite called GOES-T, again, just launched about 30 minutes ago, and we'll take a step back in history. This was the first ever satellite image of Earth from a weather satellite from Tyros from 1960. Pretty grainy, you can't really see a whole lot. Jump ahead to 1975. This was the first iteration of the family of satellites that was launched today, and a little bit of a better resolution image, but we can do a lot better with the instrumentation that we have nowadays. There's two types of weather satellites that we launch into space: polar orbiting satellites and geostationary satellites. The polar orbiting satellites are much closer to the Earth's surface, and they move over the poles north to south. The geostationary satellites is the one that we launched today. That rotates with the Earth, looking at the same side of the Earth at all times. Rotates along at the same speed of the Earth, and one location much farther away from the Earth as well, about 22,000 miles away from Earth's surface. So the GOES family of satellites stands for Geostationary Operational Environmental Satellites. And it started in 1975, as I mentioned, and there's been 18 iterations of this satellite now. This is the 18th version that we're launching today. And you can see all of the different types of technologies, what they've looked like up to now. This series is the GOES-R series that we've been launching over the past several years. This is the last in that family of satellites. And we'll show you some of this footage of what the building process looked like of the satellite. You can see the satellite being constructed there with, it's about the size of a small school bus, weighs over 6,000 pounds. And you can see with GOES East versus GOES West. This satellite is going to be on that western side, looking over mostly the Pacific Ocean and the western side of the United States. That's where the position it will be going into once it moves into orbit around the Earth. And some of the pictures that we get from these satellites are really spectacular. They update up to the minute with information of hurricanes, cloud formations, and some of the newer satellites even have lightning detection, which really helps us to pinpoint where thunderstorms are developing across the globe. These satellites can also detect space weather, so there's also an instrumentation pointed away from the Earth looking at space weather phenomena, which is also important. But you can see some of these images of it being built at the NASA facilities, and it was launched on an Atlas V rocket built by the United Launch Alliance today. So some incredible images that we get from these satellites. As I mentioned, we can also see wildfires with them, and with each iteration of these satellites, we get more advanced imagery, better resolution, both spatially across the globe, as well as more up-to-the-minute information that impacts weather forecast models and impacts how we observe weather phenomenon all across the Earth. So we'll go back to the graphics here, and I wanted to show you that launch that happened just 30 minutes ago. So it was a successful launch. The GOES-T satellite is now on its way into orbit, 22,000 miles above the Earth. We'll go into position monitoring weather all across, mostly the Pacific Ocean and the western United States, with more up-to-the-minute information, because the old iteration of the satellite that was launched about 4 or 5 years ago had a couple of malfunctions. So this new update to it is much needed, and we'll be using it in the meteorological community for observing some of these weather systems that move into our area, because with this being positioned kind of over the Pacific Ocean and the West Coast, obviously a lot of weather moves from west to east, so we rely on this satellite for a lot of important information for not only forecasting, but also observing what is happening right now.
It's so true how the technology has changed too. And just being a meteorologist, we have seen this over the years and even decades. And this one's geostationary, so it's stationary with respect to the Earth. You mentioned that well, 22,300 miles up. So it's rotating at the same rate the Earth is turning. It's a cool thing. Kids love hearing about that when you do school visits and stuff.
And imagine how much more the technology will advance, like even in 5 years.
Everything
Right?
is changing
Yeah.
all the time, but we're getting so much information. You know, back when I was first becoming a meteorologist, we may have had an image every 15, 20 minutes or
Yeah,
so.
what is it
now
now?
it's pretty much in real time, every minute or so thereabouts. So, and they get the
Crazy.
polar orbiting satellites too. So a lot of information at our fingertips.
And you think radars and weather balloons are so important for observations, but those can only be at certain point locations. Satellites all over the globe. So we can get much better information for weather forecast models. They're really an important component of our toolkit of weather information.
Good
amazing.
stuff. You did
Amazing.
so good, you get a piece of cake.
There we go.
Yeah,
I'll
just
enjoy
got
it
to
in the
find the fork.
Yeah,
so.
find a fork. I don't use fingers. Anyway, thank you, Jacob.